Okay, so what I did was I wrote the quadratic formula over here so that we could reference it. And there are a couple of different types of answers you could get. The first one we got was, it was irrational because it had a square root in it, but there were two answers. There was the plus answer and the minus answer. And so because of that x squared, we got two answers like we're supposed to. But every once in a while, we might only get one real answer, and that, we'll look at the graph, that means that it just touches the x-axis one time, okay, because it bounces off. That one answer we've talked about in the past is called a double root. It represents both answers because it only touches it. And then down in this last example, we could actually have imaginary solutions. And when we look at those graphs, that actually means that it doesn't touch it at all. It's two above or two below the x-axis to actually cross it, and that's where imaginary answers come in. Okay, so let's just look at this real quick. We're only going to get one answer because that's what it says, but we can still use the formula to get that one answer. So this is already in standard form. It already equals 0. So we can just substitute in, let's see how good this one is. Okay, so A is 2. B is -8, just watch your signs, and C is +8. See if I got a better orange. Okay, so this is the opposite of B. So since B is -8, I always think of it as the opposite. That way, whatever this is, I just put the opposite. So I'm going to put a +8 in there. Then it's -8 squared minus 4 times 2 times 8. And then it's 2 times 2 because that is A. So B's go here, A's went here, and then the C, that number 8, goes down there, okay? So again, then I go from the radical out. Well, you have to. It's not just me. You got to go from the radical out. So inside, let me get a better one. Here we go. All right, so inside this radical, okay, if you were to put it into your calculator carefully, you would get 64 minus 8 times 8, which is also 64. So you would get 8 plus or minus the square root of 0 over 4. Okay? And this is called the discriminant. We talked about that in the vocabulary. And when you get a 0, that kind of gives you a hint. Oh, well, square root of 0 is just 0. So really, that's just 8 divided by 4, which is the number 2. Okay? Because this part actually goes away. You're not adding or subtracting anything anymore, and it just becomes a really basic fraction, 8 divided by 4. So that's the number 2. So we only have one answer. And so if we were to graph that, if we were to put that on a calculator, we would see it only crosses at 2. It only crosses, like, for example, here it is. Let's say this is 2. It would just look something like that. It would only cross right there at 2. Because that represents both answers. That's our double root, okay? So when we get a 0 underneath that radical, that is when we only have one answer because the 0 makes that part go away, okay? All right, so then oh, let me scoot it over just a little bit. There we go. All right, so don't need that. All right, so now we're going to see what it looks like to get an imaginary answer. That, again, has something to do with the square root. Okay, so let's put it in standard form. So we need to get that 5 over here by subtracting it. That way it equals 0 like we want. Okay. Then we have A is, I like that purple, but I don't know if I can find it. Okay, A is a -1, B is a +2, and C is a -5 because we moved it over. All right, so we're going to substitute those into the formula. So the opposite of b is a negative 2. B squared is just 2 squared. You could put a 4 there if you want. You can go ahead and square it if you want. 4 times a, which is negative 1, times c, which is negative 5, and then 2 times negative 1. So I put my b's here, my a is there, and my c is there. Again, we work the radical. We work from the radical out. So when we do that, you could use your calculator, and you get negative 2 plus or minus the square root of 4 minus 4 times negative 1 times negative 5. And that is a negative 16. It's 4 minus 20 is what that is. And then over negative 2. Well, now we simplify, and you guys know about radicals. You guys know that a negative inside the radical means it's an I, okay? And then you also know that the square root of 16 is a 4. So this simplifies down to negative 2 plus or minus. You know this becomes 4i. Okay, plus or minus because of the formula, that becomes I, that becomes 4, all over negative 2. So again, it's just kind of layering these different parts that you already know. And then we've even talked about reducing. This is why I started talking about it last week, is because remember, you can either divide that, or if they all divide by the same thing, we can go ahead and reduce it. So if I divide both of these by negative 2, I get, let me just use black, okay? If I divide this by negative 2, I get 1 plus or minus. If I divide that by negative 2, now I do get a negative 2i, but plus or minus means you're going to do both anyway. So I can just say 2i. All right? So the solutions are 1 plus 2i, because you could add that, and 1 minus 2i. 1 is the adding answer, 1 is the subtracting answer. Kind of like when we square root, we would get a positive or a negative, okay? And then these imaginary graphs, if we were to put this into our calculator, it would actually look something like that. Because it's below, it actually would not even touch the axis. That is what makes it imaginary. When you have a negative inside of here, should point out, oh, that's an imaginary number, so that's an imaginary solution. It can't touch. So it's below it or it's above it. In this case, I know it's below because it's negative. It's a negative x squared. But that's imaginary means it's not even going to touch. And we're used to looking to see where it hits that x-axis, but this is helping us see no matter what we have or are given, we can still work it out to get an answer, okay? All right, that is all we have. On the next page, we'll keep practicing so that we can get it squared away completely, but this is the parts of using the formula and recognizing this radical to start figuring out any solution you could possibly have, okay? All right.